Consider an example. Go to your kitchen and you will find that your mom is cooking. Now let's say that she is cooking on a frying pan like the one that you can see in the picture. If you observe closely, you will find that your mother is always cooking by touching the handle of the frying pan. She never touches the body of the frying pan. Now you can ask me an obvious question that the fire is burning at the bottom of the frying pan, so obviously the bottom should not be touched. But why shouldn't the sides of the frying pan be touched? If you ask your mother, she will tell you that if the sides are touched, she will feel heat, and obviously this heat will be significant so that it can burn her skin. So this is the reason why she never touches the sides of the frying pan, and that is also the reason why you never should. So now tell me that if the fire is burning at the bottom of the frying pan, why is it that the heat is traveling to all the other sides of the frying pan, that is throughout the body of the frying pan? Why is it that the entire body of the frying pan is becoming hot? Let us find out, because this means that heat is traveling inside the frying pan from one point to another. So let us see what actually is happening. Over here, we consider a frying pan that has been kept on fire. Now, if you observe closely, you will see that the molecules in the frying pan at the end are starting to vibrate, and all the other molecules are starting to vibrate along with it. Now, this process is known as the conduction of heat. Some scientists postulated that conduction of heat takes place in the following method. As you can see, at this particular end, the fire is causing the temperature to increase in that region. So as a result, what is happening? The kinetic energy of the molecules in that place or the particles in that place is increasing because more heat is being supplied. So the moment the temperature is being increased by supplying heat, the jiggling of these particles or their vibration will increase. So as a result, their kinetic energy is also increasing. So when the molecules at this end of the frying pan start to vibrate, they cause the other molecules, that is the neighboring molecules, to vibrate as well, because their vibrations they move forward and they collide with the neighboring molecules. So as a result, they set the neighboring molecules in vibration as well. Now these molecules vibrate vigorously and they further cause the neighboring molecules to vibrate. So this continues all the way till the end of the frying pan, and the entire frying pan becomes hot. Now some scientists say that conduction of heat does not take place in this way but through another way. Now in the previous case you saw that the atoms did not leave their position. That is, they only vibrated to and fro about their mean position, but they did not move forward. It is only the vibration that moved forward. Now some scientists believe that it is through the vibration of atoms that heat is conducted, whereas some scientists believe it is through free electrons the heat is conducted. Now in order to find out what that theory is, we must first revisit the concept of free electrons. Now we have studied that an atom is the most fundamental unit of matter, which consists of a positively charged nucleus and negatively charged electrons that revolve around it in several shells. Now if we consider the outermost shell of an atom, the electrostatic force between the nucleus and electrons in the outermost shell will be very weak because the distance has increased, and we know that electrostatic force decreases with increase in distance. So these electrons will be weakly held by the nucleus, as a result of which they will be free to move around in the entire body of the solid. So as you can see, these free electrons are moving around randomly inside the solid. So scientists have postulated that it is with the help of these free electrons that heat is transferred. What happens when we are supplying heat at one end of the solid? Let's say at the left end, the free electrons in that region are absorbing this heat and their temperature is getting increased. So as a result, they start to jiggle or vibrate more. Due to their increased vibrations, because of the increased temperature, their kinetic energy increases. And as I mentioned, due to their increased vibrations, they collide with the neighboring free electrons. So as a result, they transfer their kinetic energy to them through these vibrations, but then these free electrons return to their original position. Now, these free electrons have transferred the vibration forward to the neighboring free electrons. So these free electrons now start to vibrate with a greater amount of kinetic energy. So this process is carried on till the entire vibration reaches from this end to the other end of the solid. So as we can see that in atoms, in conductors, heat is transferred from one end to the other through both vibration of atoms as well as vibration of free electrons. It is important to note that neither the atoms nor the free electrons are actually moving forward. It is only the vibration that is moving from one end to the other, as a result of which heat is getting conducted. The atoms and free electrons keep vibrating in their own position only. They do not move forward. So because in solids, conduction is taking place through the vibration of atoms as well as electrons, heat is conducted very fast in solids. So how can we now define conduction? Conduction is the process of transferring heat energy from one end to the other, that is from one atom of a solid to the neighboring atoms of the solid, in the direction of lower temperature. That is, the heat is transferred due to the vibration of atoms and electrons from the hot end to the cold end. And as I mentioned, there is no visible movement of the atoms. In other words, the atoms do not move from their position. That is the original position where they were at. It is only the vibration that moves forward, and thus the heat energy travels from the hot end to the cold end. This transfer of heat energy is very similar to how these people are passing a parcel among them. As you can see, none of them are actually moving from their place. They are simply handing over the parcel to the next person, and this is how the parcel is getting transferred from the first person to the last person. Similarly, conduction takes place where the medium particles do not move. It is only the vibration that gets carried forward from the hot end to the cold end. Now consider a very interesting scenario over here. We are heating a metallic rod by keeping one end of it on the fire. Now if you observe closely, the end that is being heated is becoming red hot gradually. Now do you know what is happening? When we are heating this rod, what happens is the end which has been kept on fire is increasing in temperature. So as a result, their kinetic energy is increasing as it absorbs more and more heat. Due to this increase in temperature, the kinetic energy increases, and a part of this kinetic energy is given out as light energy. So as a result, we are able to see this particular end turn red. And as the entire metal rod gets heated by the process of conduction, we are able to see this red color rise from one end of the rod and move towards the other end of the rod. That is, from the hot end to the cold end. So what did we learn? We learned that conduction is a method of heat transfer that takes place in solids. In conduction, it often occurs due to the vibration of atoms as well as the vibration of the free electrons. So due to this reason, conduction takes place very fast. The heat energy thus is transferred very fast from the hot end to the cold end. Also, there is no visible movement of the atoms. In other words, neither the atoms nor the free electrons actually leave their position while conducting heat. They only ensure that the vibration moves forward in the direction that is from the hot end to the cold end.